Okay, so hey everyone, today we are going to discuss Vlad and the division from Codeforces around 9 to 8, and let's get into it. So this guy has n integers. He wants to divide all of them into several groups so that any group any pair of numbers does not have matching bit values from 1 to 31st bit, right? Like this is one based indexing, so keep this in mind. Right, they are giving example right here, like what do they want, and they're indexing from right to left, indexing from one. So I'll just explain the question in my words. So read this. Formally, for any two numbers x and y in same group, the condition is any bit of x should not be equal to y must hold for all uh, I belongs to 1 to 32, right? So what is the minimum number of groups Vlad needs to achieve his goal? Each number should fall exactly into one group. So the question wants to say, let's we know that wait a second. We know that integer contains 32 bits, right? And it would be something like this. And I'm using zeroth based indexing, so we'll be careful about one based and zeroth based. This is zeroth bit, this is 31th bit, right? Total 32, right? And the last bit, this MSB, this is called the most significant bit. This is basically sign bit, right? And basically if this bit is positive, then number is negative, and if this bit is unset, then the number is set to be positive. So basically we would be using these bits, these 31 bits, for our question. Then what do we have condition for grouping? If you read carefully, any pair of numbers uh, in any pair of numbers does not have matching bit values from 0 to 31st bit in a single group. That basically means uh, it's very simple observation. Let's say we have a number something like 0 0 0 0 0 1 0 and trailing zeros, right? Here are all zeros. So this is say number A, and we have some another number which has 1 1 1 1 1 up to 31st, and then 1 1 1 1 1 1 again, basically complement of this, and 0 1 0 and 1, basically A uh, B is complement of A, right? If you know the complement, 0 complement is 1, 1 complement is 0, so basically not. Yeah, so if you observe, group has at most two elements. Observe this carefully, like because group can contain a number and its complement. The group may look like this. It may consist of a number and its complement, number bar, or you can just say, or group might be single also, like it does not contain anything. It does not contain the complement of a number but number itself. So these are only two possible cases, this case and this case. Other cases won't be possible, like we want the bits to be different, right? So this is the only possible. Number has different bits only in the scenario like if it's each bit is different, so for getting each bit as different, the only number which has each bit as different from number is number complement. So think about this, how is this condition getting valid? And if we do not find the complement in the array, then we can just have a number into a single group, right? Like if n complement does not exist in array given, right? So these are only two cases in which our group can be divided. So I think this explanation makes it pretty clear how to go further. Just remember this complement condition. So this was my whole intuition, and for the implementation idea it might vary from user to user. My idea was something very simple like this. Basically I'll traverse through the array and check if I have number and its complement. If I have them both, I'll increment my count. What I'll do is traverse through the array, and if I have number and its complement, like I have encountered number here, and I have somewhere like in the array, or like let's say I have used set, actually multiset. So if I have number and number complement in this, I'll increment the count by 1 and I'll remove them from this set as I'm incrementing the count. Basically count variable stores groups with group number of groups with two elements in it. Basically this group, case 1 groups, right? And now as we remove the element from the set like this, like whenever we encounter number and number complement, we are incrementing the count and removing it from the multiset. So this way our set will only consist of, then our set would be only left of numbers with no complement, like numbers without complement present, without its complement. Now try to process these two things, like why is this true? Think about it, or I'll show you the code later. And now one more important part, how do we calculate complement of a number for 31 bits? Say we had a number, we want to calculate its complement. So there are two methods to do this. One is like what I have done in my implementation is just I have taken the number complement, like taken a NOT gate of number, so all 32 bits get reversed, right? Or say set to unset and vice versa, right? Now what I want is my 32 bit to not change, right? And then basically I don't want my 32 bit to become 1, I want it 0 in 1 based indexing. Like I don't want my MSB to change. So what I'm doing is I've got this number in which all 32 bits are reversed. Basically all 32 bits are reversed. So what I'll do is I'll take a number that is 1 right shift 31, right? This number would look something like this, right? This is 32th bit and this is first bit if you are talking about 1 based indexing, right? And I'm taking its not 1 right shift 31, so its not would look something like this. Zero, one, 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 like till the end. This is the first and this is 32nd bit. So when I'm taking, and like what I'll do is take AND operation with this number 0 1 1 1 1 1 1 up to this. What this will do is basically set my 32 bit as 0 no matter what, like no matter the bit of number it's 1 or like number complement it's 1 or 0, it will set it as 0 because we know uh, a dot 0 where dot is and a and 0 would give me 0, and another basic property is a and 1 would give me 1. So other this bits would preserve the number complement, and 0 and this thing would change it to 0. So these are two properties you should know about, right? And this expression, basically the final expression would look something like this: complement of number, wait, I'll write with white, complement of number taking AND with taking the AND with not of 1 left shift 30 right shift 31. This would be my number complement for 31 bits, right? There's one better way to do this. I'll discuss this also. If you want, you can skip the current part and move directly to code, but I'll discuss the current part also. Second part would look basically like, you should know XOR, right? Basic properties of XOR is X XOR X gives me 0, and X XOR X bar gives me 1. Let's visualize this. While this holds, like take an example. Let's say we had X as 0 1 0 0, and then X bar would look something like this: 1 0 1 1, right? When you take the XOR, like 0, like bitwise XOR, 0 XOR 1 1 XOR 0, like this and this whole thing would be equal to 1, right? 4 bits, right? So any number, basically when you take XOR of any number with its complement, you would get all ones, right? And the reverse, like if you take XOR of a number with all the ones, then you would get this X complement. Like try this: 1 0 0 0 XOR with 1 1 1 1 would give you 1 0 1 1. Give it a try. Like 0 0 XOR 1 would give me 1, 1 XOR 1 would give me 0, and 0 XOR 1 again, 0 XOR 1 again gives me 1 and 1. So we obtained, what we obtained here is basically X bar. That is what it want, right? So the another way you can compute number complement equals to a number XOR of 1 1 1 1 1 1 up to 31 bits, right? Yeah, and yeah, so this would be 0 32 bit. Like let's just say this is 0th best indexing. Wait, I'll just write it very properly. XOR with this. This is our 31st bit, and this is our 0th bit, and this is signed. So Yeah, this would be 0 in both of the cases, as in so as in number we would have 31st bit as 0, like here also we would have 31st bit signed bit as 0 as positive integers, like we are given positive integers, so that won't be an issue here. So in this method, like, and this number right here, like 0 to first 31 bits is basically int max, right? If you observe carefully, like int max looks something like this. The first bit represents signed, and then other bits are all one, all set, right? So this is another way in which you can obtain number complement. So basically number complement equals to number XOR of int max, as simple as that. What I have done in code is using the first way, but you can do this using the second way also, which is much better. Yeah, I'll just go into the code so you'll understand. This is my submission. I'll just take a screenshot. So what I'm doing here is taking the input for n, and this is the test cases loop, and now I'm creating a multiset. Wait, I'm creating a multiset right here, so test, and creating a count variable. Which count variable, what does count variable store? It stores the number of groupings in which the size of grouping is 2, right? And the multiset would store grouping of size 1. I'll just write it down again. S would, at the end, S would store groupings of size 1, and count would store number of groupings of size 2, right? So this is, I'm using the range based for loop, and this in this process, using step 1, I'm calculating my number complement. X is basically my element complement of 31 bits, 1 to 31. So, and now I'm checking, like, this is important part, so please be careful. I'm checking if I can find X in my set. If I find X in my set, I'll increment the count, and I'll erase the X. I'll delete that X, and I won't insert our element. Right? What I'm doing, let's say we have an element here, and we have X right here in set, in multiset to be precise. Right? And X equal to elements complement. So what I'm checking, if I find X, if I find some X which is complement of element, so I can write this X as element complement. If I find the element complement in the set, I would increment the count. I'd increment the count and remove this element complement from set. I won't insert this element, and I would remove this one. So this would be removed from multiset, and this grouping would be formed, and we would increment the count like this, right? I think this makes it pretty clear how I'm able to think it. Now if the number complement does not exist in the set, if let's say we do not have element complement in the set, right? If this is the case, we would, let's say, element 2 el2, if we do not have el2 complement in the set, we do not have EL2 complement in the set, then what we would do is just insert the EL2 into our multiset. So we would just insert our EL2 into our multiset, and we would repeat this process for all element in our original array, original vector. And at the end we would just show the we would just print the size of grouping. We would just print number of two groupings and number of one groupings, as set would store number of one groupings and count would store number of two groupings, right? And this would be our answer. So that's it. Thank you.